Saga stands for the simple API for grid applications. And its history lies in the fact that over the past some years, as infrastructure has been changing, it's realized that it's getting progressively harder for applications to utilize the many advances in infrastructure. So in an attempt to try to make it easier for applications to utilize and exploit infrastructure effectively, what is required is an abstraction layer. And Saga represents the first global effort to try to make this happen. It's global in the sense that groups from at least half a dozen countries and half a dozen different projects got together and realized that they need to have a consensus on the interface that is developed and that application developers will use. Because it's no point having a set of applications use their own interface and that interface not be supported on the range of different distributed infrastructure, because then you're back to square one, where you'll be able to develop an application that will only use a specific set of infrastructure. So over the past 3 or 4 years, researchers here at CCT, including myself, have been leading this global effort. And I think it's very important to mention that CCT has been instrumental in making this happen. And not just the specification, we're also the leaders in implementing this specification. And our group here at CCT is providing the first complete reference implementation of Saga, which will be available for researchers, computer scientists, application developers throughout the world. And I think this is a major achievement of which there'll be much more to say over the next few months as it becomes more and more widely taken up by many groups. Grid computing or distributed computing does relate to material world. It's the enabling technology for a lot of the science that we do in either materials, soft materials or hard materials. Personally, I work more on the soft materials side, but distributed computing is really an important mechanism to be able to do to address a lot of the challenging science problems that are inherent in many of these areas of materials. Specifically, what grid computing lets us do is couple resources in a reasonably seamless and transparent manner in order to be able to utilize a lot of these high-end computers as well as specialized hardware for specialized problem-solving techniques or problem-solving environments, as we'd call them. One of the specific interesting things that grid computing allows end users and scientists to do, which wouldn't be possible otherwise, is to adapt the resource requirement in ways that suit the application as opposed to adapting the application to suit the resources. And that's very important for end users, for the end scientists, not to have to change the way they do their science, but for the infrastructure to adapt to their science. So, and I think over the years it's a difficult task, and over the years grid computing's gotten better in adapting resources and distributed environments to the requirements of end users. One particular way of doing this is something through Saga. And what Saga lets end scientists do is to write their scientific application just once in a uniform at a high level, and then not have to worry about the low level changing details. And so whether they run on the Terra grid or on a European grid or on a Japanese grid, Naregi, the scientific application once written doesn't have to be changed. And that's very, very important so as to not have the end user constantly changing based upon the underlying environment. Now, what Saga does is it provides this high-level interface which then has the underlying mechanisms and adapters to make the appropriate calls in an intelligent fashion so that it can work on any underlying grid system, once again, whether it be Terra grid or the European grid or so on and so forth. Through Lonnie, we have one of the most powerful machines, not just on the Terra grid, but one of the most powerful machines available to academics anywhere, and that's Queen Bee. But once again, Saga enables the coupling of Queen Bee to other distributed resources on the TerraGrid and elsewhere. For example, we had this paper at the TerraGrid 2008 conference, which won the Performance Challenge Award. And what that paper really was trying to display was the ability for it to couple Queen Bee, resources at TAC, resources at NCSA and San Diego at the application level towards a single application requirement. So for a single scientific application, the ability to couple these high-end machines seamlessly without ever really having to change the application code. That's really what Saga does and what it really means to the end user, to the scientist, in terms of coupling these many resources. So yes, we use Queen Bee, we use the other important TerraGrid resources, but ultimately the important thing is to be able to use these powerful machines without really having to change the usage mode, without really having to change the application to be able to exploit these resources. There are other Lonnie resources which we do use for many of the other scientific applications. There are the powerful IBM machines and also the Dell clusters, which are located at 5 of the different Lonnie sites. And trying to use these in a collaborative and coupled manner remains a challenge, but is getting there. It's becoming much easier, and we're trying to use this for effective science at the end of the day.